We will now find the Laurent series expansion of the function of f of z is equal to 1 divided by z plus 1 into z plus 3 in the region. Okay. The first part will be 1 less than mod z less than 3. Okay. And the second one will be 0 less than mod z plus 1 less than 2. And the third part will be mod z greater than 3. And the fourth part will be mod z less than 1. So what we will do is we will discuss the convergence in these regions. So before proceeding with the solution, we first use the partial fractions to separate this term f of z into linear factors. So I'll have a by z plus 1 plus b by z plus 3. So 1 will be a into z plus 3 plus b into z plus 1. So when I substitute z is equal to minus 1, I'll have 1 is equal to a into minus 1 plus 3, which implies a is equal to 1 by 2. And when I substitute z is equal to minus 3, you will have 1 is equal to b into minus 3 plus 1, which implies b is equal to minus 1 by 2. So f of z will be 1 by 2 times 1 by z plus 1 minus 1 by z plus 3. Okay. So this will be the first part. So first what we do is we divide or separate f of z into linear factors like this. Now a, the region is 1 less than mod z less than 3. How does this represent? You have two circles. Mod z is equal to 1 and mod z is equal to 3. This will be 1 and this will be radius 3. So this region represents this annular region, that is in between the circle. Mod z is equal to 1 and mod z is equal to 3. So now what you are going to do is you are going to discuss the region of convergence in this. Okay. So before that we will remember certain results. What is 1 plus x whole power minus 1? 1 minus x plus x squared minus x cube plus so on. And then 1 minus x whole power minus 1. This will be 1 plus x squared plus x cube plus so on. And then the next one will be 1 minus x whole power minus 2. This will be 1 plus 2x plus 3x squared plus so on. Okay. Depending upon the region of convergence, what we will do is we will expand the terms of f of z. Okay. So here in this case the region of convergence is 1 less than mod z less than 3. Okay. So now what I do is in 1 by z plus 1, I will remove 1 by z as a common factor and I will have 1 by 1 minus z whole power minus 1. And if I want to expand this modulus of 1 by z has to be less than 1 or 1 will be less than mod z in this case. For the second term I require, for the second part I require mod z less than 3. So in 1 by z plus 3, I will take 3 as a common factor and I will expand 1 plus z by 3 whole power minus 1. And when I expand this, I will have modulus of z by 3 less than 1, which will give you mod z is less than 3. And when I combine these two, I get the region of convergence as 1 less than mod z less than 3. So now how do we do it? So now I have f of z. What is f of z? F of z is equal to 1 by 2 times 1 by z plus 1 minus 1 by z plus 3. Okay. Now this 1 by 2 will be there. I will have this 1 by z as a common factor and I will have 1 plus 1 by z whole power minus 1 minus 1 by 3 into 1 plus z by 3 whole power minus 1. Okay. So this will be 1 by 2 times 1 by z into expansion using binomial theorem. 1 minus 1 by z plus 1 by z squared minus 1 by z cube plus so on minus 1 by 3 times 1 minus z by 3 plus z squared by 9 minus z cube by 27 plus so on. So now this is valid if modulus of 1 by z less than 1 and modulus of z by 3 less than 1. So when I combine these two, I will have 1 less than mod z less than 3. So this will be the Laurent series expansion in the given region. 1 less than mod z less than 3. This completes part A. Now we will solve part B. Now what is this B? You have to expand the same function f of z is equal to 1 by z plus 1 into z plus 3 in the region 0 less than mod z plus 1 less than 2. So the terms in the Laurent series should contain z plus 1, not z as in the previous case. So what I do is I will assume z plus 1 is equal to u. So this function g of u will be 1 by u into u plus 2. Again I will use the partial fractions and split this a by u plus b by u plus 2. Okay. So 1 will be a into u plus 2 plus b into u. When I substitute u is equal to 0, a will be 1 by 2. And when I substitute u is equal to minus 2, b will be minus 1 by 2. So g of u will be 1 by 2 times 1 by u minus 1 by u plus 2. Okay. So because I have assumed z plus 1 as u, the validity becomes 0, 0 less than mod u less than 2. So what I will do is I will retain this 1 by u as such. and in this I will remove 2 as a common factor, and I'll have 1 plus u by 2. So this turns out to be 1 by 2 times 1 by u minus 1 by 2 into 1 plus u by 2 raised to the power minus 1. And when I expand this using the binomial expansion, I'll have 1 by 2 times 1 minus u by 2 plus u squared by 4 minus u cube by 8 plus so on. And this is valid only when mod u by 2 less than 1, binomial expansion. So now what I will do is I will replace u with 1 by z plus 1. So I will have u with z plus 1, I will have 1 by z plus 1 minus 1 by 2 times 1 minus z plus 1 by 2 plus z plus 1 whole squared by 4 minus of z plus 1 whole cube by 8 plus so on. This is valid if modulus of z plus 1 less than 2. Of course, it has to be greater than 0. So in this case, if you look at the previous case, in the previous part you had the interval as 1 less than mod z less than 3. 1 less than mod z less than 3. So you had expanded in terms of z minus 0 or z. But whereas here you have to expand in terms of z plus 1. And if you want to expand in terms of z plus 1, you substitute u is equal to z plus 1 and expand u, that will give you the required expansion. And of course the validity of the region or the convergence of the region automatically gets adjusted. So this will be the second part. Now again for the third part, what you do is see f of z. I'll just write down the form which we obtained in part A. 1 by 2 times 1 by z plus 1 minus 1 by z plus 3. Okay. Now you have to see is valid in mod z greater than 3. Okay. So the region of validity is changed from 0 less than mod z plus 1 less than 2 to mod z greater than 3. That is exterior to the circle, mod z is equal to 3. Okay. This you can do like this. F of z is equal to 1 by 2 times. I'll remove this 1 by z out, and this will be 1 by 1 minus z whole power minus 1. And again minus 1 by z into 1 plus 3 by z whole power minus 1. So when I expand this will be 1 by 2z. You can remove this 1 by 2z. When you expand this, you will have 1 minus 1 by z plus 1 by z squared minus 1 by z cube plus so on. This will be the expansion of 1 plus 1 by z minus of, I'll have 1 minus 3 by z plus 9 by z squared minus 27 by z cube plus so on. Okay. This will be the expansion of f of z. Now what I have to do is I have to test the validity. The first series is valid when modulus of z is greater than 1. And the second series is valid when modulus of z is, first series is valid when modulus of z is less than 1. And the second series is valid when modulus of 3 by z is less than 1. or this will imply 1 less than mod z and 3 less than mod z. And now when I take the intersection of these two, I'll have the validity to be mod z greater than 3. So this expansion is valid in mod z greater than 3. See, now you can see this is very simple. This will be mod z is equal to 1, and when I take a larger circle, namely mod z is equal to 3. Okay, in this case what happens here is that the region of convergence or intersection of these convergence will lie in this part. So automatically, because mod z is greater than 1 and mod z greater than 3 has got this intersection, this expansion will be valid when mod z greater than 3. When I take mod z greater than 1, then the second part cannot be expanded, and therefore we take the common region and say that the validity is mod z is greater than 3. Okay. Now for the fourth subdivision D, again I take the value of f of z as obtained in part A, 1 by 2 times 1 by z minus 1 minus 1 by z plus 3, and validity here valid in mod z less than 1. Okay, so in this case, in the previous problem you had the validity in mod z greater than 3, you have to find expansion. Now you require the expansion in mod z less than 1. So now what I do is, I will remove this constant so that I get the required answer. I will have 1 by 2 times. I can write this as 1 plus z whole power minus 1, because when I remove this constant 1, I will have 1 plus 1 by z whole power minus 1. And for the second term, I will remove this 1 by 3. I will have 1 plus z by 3 raised to the power minus 1. So when I expand this, I will have 1 by 2 times 1 minus z plus z squared minus z cube plus so on. Okay. Minus 1 by 3 times 1 minus z by 3 plus z squared by 9 minus z cube by 27 plus so on. Okay, this will be the expansion. Now I will test the validity. First one is valid if modulus of z is less than 1. And the second one is valid when modulus of z by 3 is less than 1 or mod z less than 3. So here when I take the common region, I will have the unit circle. I will have the unit circle as the region, validity region. Because here mod z less than 1 will be the circle. Mod z less than 3 will be the circle interior to mod z is equal to 3. And the intersecting point will be this. And of course you can see here, when I draw, sorry, I'll take another color. When I draw this, and you can see that the common region will be interior to this circle, and therefore it is valid in mod z less than 1. So in this case, the expansion in terms of powers of z and negative powers of z. Here you have everything to be positive. In the case mod z greater than 3, you add negative powers. So the Laurent series is a series which contains term of the form 1 by z and z, and you should necessarily give the validity when you expand the given function f of z using the Laurent series. This completes this problem.